Hello students, I am coming for a new video class now. I am discussing class 12 topic electrostate, how to calculate force acting on a point charge by a big size charge object. Initially we discuss rod, point charge getting force because of a rod, then because of a ring, then because of a disc, and finally a hemisphere also done. I am just discussing one more question of this kind where one rod present but it is different than whatever we initially considered. Look at that. Say this is one rod I am considering. This is one thin uniformly charged rod. Say this rod of charge density lambda. One point charge present at a distance, say capital R from it. A point charge present here. We have to calculate force acting on the point charge because of the rod. Previously also we discussed a question of force acting on a point charge because of a rod, but in that case point charge is along the length of the rod. Here point charge is in the perpendicular direction of the length of the rod. Okay. My advice is first you write the question. Whenever you come to my class, you must come with pen and paper. You should be ready with that. Okay, write the question. Right. Figure shows a thin uniformly charged rod having linear charge density lambda. A point charge small q is placed at a distance r from the rod. Find the force acting on the point charge q. Now how to do calculation? Written total charge of the rod nowhere written. Instead of that one word written or one sentence written, linear charge density. So name suggests charge is present along the length. So along the length of the rod, charge density meaning charge per unit length. Linear charge density meaning charge per unit length is lambda. To calculate force acting on the point charge, our Coulomb's law is valid for the point charge but not valid for this rod. Why? Because rod is a big size object. What to do? I am doing calculation like this. The point charge q is distance of the point charge q is measured from this point. So for my calculation, I am considering this point as origin. From that, I am considering this is origin. From that, at some x distance, I am considering a dx portion. I am considering a dx portion here. This dx portion carries a charge say dq because whole rod will be carrying some charge not mentioned. Charge of this dx portion only this portion. It is what? Lambda into dx. Why? Charge per unit length is lambda. For dx length it is lambda into dx. Because of this small portion, it is a small portion like a point, my point charge q will be getting a repulsion in this side. This force I am writing df. So what is df? Let me write. df according to Coulomb's law, because this is a point charge and this is a very small portion like a point. So it is 1 by 4 pi epsilon naught q into charge of this portion dq by square of this distance. This is r, this is x. So this distance is actually r square plus x square under root, but square of under root, so under root goes away. So I am writing 1 by 4 pi epsilon naught q into dq divided by 4 pi epsilon naught r square plus x square. I am calculating force acting on this point charge because of this portion. What is dq? Available in the question, meaning indirectly dq for this portion is lambda into dx. Why? Because linear charge density is lambda. So lambda is given in the question. This is written charge per unit length. So for dx length, charge is lambda into dx. This is a very small portion dx. So if you write 1 by 4 pi epsilon naught q present, dq is lambda into dx divided by r square plus x square. Now what is df? The direction of that repulsive force like this. If you consider that portion not here, somewhere here or somewhere here or somewhere here, force will not be in same side. If you consider the portion somewhere here, force will be like this. If you consider the force because of a portion here, force will be in this direction. So all not in same side. So we must break into components before we do calculation. So this angle theta, this one theta. A part in this side, this is df cos of theta, and a part in this side, this is df sin of theta. So automatically the force df is broken into two parts, one df cos of theta, one df sin of theta. One df cos of theta perpendicular to the rod, one df sin theta parallel to the rod. So two force present. I am writing force in perpendicular direction first, meaning this one, it is integration of df cos of theta. I hope no difficulty in that. So what is df available? It is q lambda by 4 pi epsilon naught, 1 dx present divided by r square plus x square also present. What is cos theta? I am just writing it here. Cos theta we can replace from the drawing. Clear? I am just writing cos theta here. Cos theta we can replace from the drawing. Cos theta is base by hypotenuse. In that way, cos theta, if you write from the figure, it is r by under root r square plus x square. I have no difficulty in that. So in that way, q lambda r by 4 pi epsilon naught integration of dx divided by r square plus x square to the power 3 by 2. Just what is dx written here as a variable, cos theta is r is a constant, so kept outside. Okay, this integration again directly no result available, so some manipulation required. In my drawing the answer available. Look at the figure. From the figure there is a relation between x and r. What is that? Tan theta we can write x by r. So we can write x equal to r tan theta. Let me differentiate x with respect to theta. R tan theta on differentiation sec square theta d theta. Sorry, sec square theta. I am differentiating both sides with theta. X on differentiation dx by d theta, r outside, tan theta on differentiation sec square theta. So dx can be written as r sec square theta d theta. So if you write the value here, I am just continuing in the actual format. Q lambda r by 4 pi epsilon naught integration sign present. Dx is this, capital R sec square theta d theta, bracket r square present. What is x? X is our r tan theta, it is coming from the drawing. So it is r square tan square theta to the power 3 by 2 present. Now we are getting some clue of simplification. How? R square can be taken common, 1 plus tan square is sec square theta to the power 3 by 2, so it is sec cube theta. So some simplification nicely coming. Look at q lambda by q lambda r square, 1 r already there and 1 r coming from here, by 4 pi epsilon naught. It is sec square theta d theta divided by r cube into sec cube theta. Why sec cube theta? Look at r square actually common. 1 plus tan square theta is sec square theta. So it is r square sec square theta to the power 3 by 2 present. So 2 goes cancel, all coming in cube. Okay. R cube and r square simplification possible. It is q lambda by 4 pi epsilon naught r. Sec square theta by sec cube theta, meaning 1 by sec theta. So it is cos theta d theta. So ultimately the whole integration coming in the form of cos theta d theta, where what is theta? Theta is this angle. Now how can we integrate this portion? If you go on changing up to this highest point, that angle becomes here say theta 2. Clear? If you just go on increasing the height of the dx portion to the top of that thin rod given, then angle becomes theta 2. And if you bring down this one to the lowest point, whatever angle available, say it is theta 1. So to cover the whole rod, we have to integrate it from theta 1 to theta 2. But be careful, this was our origin. Below origin negative, above origin positive. So it should be minus theta 1 to theta 2. Why minus theta 1? Because theta 1 measured below origin, theta 2 measured above origin. Just relate the drawing. So force in perpendicular direction is q lambda by 4 pi epsilon naught r cos theta on integration sin theta, limit from minus theta 1 to theta 2. So it will be q lambda by 4 pi epsilon naught r. It is sine of theta 2 minus sine of minus theta 1. Actually always final minus initial. We know sine of minus theta is minus sin theta, so that minus becomes plus. So force in perpendicular direction is q lambda by 4 pi epsilon naught r sine of theta 2 plus sine of theta 1. So whatever answer coming, it is actually one part of the total force. Why? Whatever df considered, df carries two parts. One df cos of theta and the other one is df sin of theta. We consider only df cos of theta, that is in perpendicular direction. So I am writing force in perpendicular direction is q lambda by 4 pi epsilon naught r sine of theta 2 plus sine of theta 1. Still one other part present. Let me continue with this. If you look at the other part, I am drawing separately for the other part. If you look at the other part, same rod present, same origin, same point source at r distance, same dx portion at x distance. It is carrying the same charge, actually same rod drawn. This is the force because of the small portion carrying charge dq. This was df, this angle theta, so this is theta. In this side df cos of theta, whose calculation done. In this side df sin theta, whose calculation I want to do now. So I am concentrating on this one. So I am writing separately. Force in parallel direction now, meaning parallel to the rod. Previously perpendicular to the rod measured. I have no difficulty in that. It is integration of df sin of theta. Clear? What is df? In the previous part of the calculation written, what was our df? Df is this value. Df is this value. It is integration present, we will do it. 1 by 4 pi epsilon naught q lambda dx by r square plus x square. Here one sin theta present. Previously in the calculation we are doing force in perpendicular direction, there was a cos theta. Now there is a sin theta. Okay. Now what is q, what is lambda, what is 4 pi epsilon naught, these are all outside. What is sin theta from the figure? X by this. Clear? If you write sin theta from the drawing, it is x by under root of r square plus x square. I have no difficulty in that. So sin theta is x into dx. Dx is already there actually. It is r square plus x square to the power 3 by 2y. Initially r square plus x square already present, and here one under root r square plus x square. So this is the expression. We will use the limit later on. Just look at this integration, how to do. Already one such idea discussed. I am just using it. What to do? I am going to complete this calculation. Clear? This is the calculation we should complete. For that, let me consider this term. I am considering this term. Let z square equal to r square plus x square. I am differentiating with respect to x because x is the variable. So it is twice z dz by dx. R is a constant because the distance is fixed. X square on differentiation twice x. So 2 goes cancel. Z into dz equal to x into dx. It is z into dz equal to x into dx. Is that clear? Once this is available, let me come back to the calculation. Force in parallel direction we are calculating. Q lambda by 4 pi epsilon naught present. Integration is there. Instead of x dx, I am going to write z dz. Instead of x dx, I am going to write z dz. Instead of r square plus x square, look at r square plus x square is our z square. So we will write z square. Don't forget to write to the power 3 by 2. So to the power 3 by 2 meaning this 2.5 goes cancel. It is z cube. So force in parallel direction is q lambda by 4 pi epsilon naught. It is integration of dz by z square. I have no difficulty in that. dz by z square. dz by z square, till now limit is not written, intentionally not written. Wait, once everything becomes clear, we will put the limit. Till now nothing coming clearly. Q lambda by 4 pi epsilon naught dz by z square on integration of dz by z square is minus of 1 by z. Minus is kept outside. Q lambda by 4 pi epsilon naught. Clear? Minus is already written outside. What is z? Actually z square is this. Under root of z square is r square plus x square. So z is under root of r square plus x square. We can modify it slightly like this. Clear? All about putting the values properly. Just look at. This is x. Here x is the limit. So x in maximum will be in this side. Say x2. And in this side, clear, x1. So here measure above, here measure below. So it should be starting from below x1. Minus x1 to plus x2. Why minus x1? Because it is below origin, and why plus x2? Because it is above origin. Initially also we consider below origin negative, above origin positive. Let me put my value. Minus of q lambda by 4 pi epsilon naught. Always final minus initial. So r square is as this present. It is x2 square. 1 minus sign present. 1 by under root. R square is already there. Minus x1 square, like this. I am going to put the minus in. This minus automatically goes away because on squaring this is not there. So it is q lambda by 4 pi epsilon naught. It is 1 by under root r square plus x1 square minus 1 by under root r square plus x2 square. I hope no problem in the calculation. Now, let me slightly modify it. So I want to multiply all the term by r. I want to divide it by r also. Clear? This is the term. Next step I am writing q lambda by 4 pi epsilon naught capital R. So I am writing r by under root r square plus x1 square minus 1 r by under root r square plus x2 square. Now it is interesting now. Clear? This distance is x2. If you look at this angle theta 2, what is sine of theta 2? Look at the drawing. What is sine of theta 2? It is perpendicular by hypotenuse. Perpendicular is x2. Hypotenuse is under root r square plus x2 square. Similarly, if you join this line, if you consider this angle theta 1, clear? What is sine of theta 1? x1 by this one. So you just write their values. So it is q lambda by 4 pi epsilon naught r. Here it is sine of theta 1 minus sine of theta 2. So only the angles you should write. Clear? Already plus minus considered, no need to consider it now. F in parallel direction is given by this. So this is the expression of how to calculate force. Actually it carries simultaneously two forces, one in perpendicular direction, one in parallel direction. Now look at the result. In parallel direction, whatever force, it carries a minus sign. By chance theta 1 and theta 2 equal, in that case force in parallel direction will be 0, but force in perpendicular direction will be always there. Look at, force in perpendicular direction was given by this relation. Here sine of theta 2 plus sine of theta 1, meaning whatever be your theta 2 and theta 1, this value will be always there. But force in parallel direction, as the derivation just done, force in parallel direction coming in q lambda by 4 pi epsilon naught r, it is sine here some calculation mistake is done. Here look at, here the calculation mistake in that minus sign. Here it is r by r square plus x square. So r by r square plus x square is actually cos of theta 1, sorry. And this answer is r by r square plus x square is cos of theta 2. So force in parallel direction coming in cos, and force in perpendicular direction was in sine. This is the answer in sine. Now the answer should come out in cos. Cos of theta 1 minus cos of theta 2. There was a slight calculation mistake in the last step for force in parallel direction. You can very easily do it from your side. Simple. The point was, in case of modification up to this mathematical step 100% correct. In this modification, here it is r by under root r square plus x square. Look at the drawing. It is r by under root r square plus x square. X1 is this, and this is r by under root. Look at the drawing. R by under root r square plus x2 square. So it should be cos, because base by hypotenuse. So wrongly written by me as sine. So please correct that calculation. So I am giving you the advice that all the calculation you should do from your side. Any error in clear this kind of observation can be very easily done. So whatever answer coming, it is divided into two parts. One force in perpendicular direction, one force in parallel direction. In both case, clear, common part is same, q lambda by 4 pi epsilon naught r. In perpendicular direction, sine of theta 2 plus sine of theta 1. In parallel direction, cos of theta 1 minus cos of theta 2. I hope the idea clear. Please go through the calculation. If any difficulty, you can comment in the video. Just my advice is, try to do whole calculation by using pen and paper. Just don't copy it directly. Do everything from your side, then match with the result. Okay, thank you.